Battery key players. 1. Na, K pump, sodium potassium ATPase. 2. K leak channels. 3. Na leak channels, minimal. 4. Negatively charged proteins inside the cell. 1. Na, K pump, active transport, pumps 3 Na out and 2 K in, using ATP. Creates a concentration gradient, more Na outside, more K inside. K leak channels, passive diffusion, K wants to move down its gradient, right pointing arrow leaks out of the neuron. Since K is positively charged, this loss of positive charge makes the inside more negative. 3. Negatively charged proteins inside cell. Large anionic proteins, e.g., phosphates, amino acids, are trapped inside. They cannot leave, adding to the negative charge inside. 4. Slight Na leak in. A small amount of Na can leak into the neuron, but not enough to counteract the K loss. Downward trend result. These combined effects generate a stable resting voltage of about -70 millivolts, with inside equals negative, outside equals positive. First stage, small diamond resting state, -70 millivolts. Neuron is polarized at -70 millivolts. Maintained mainly by K leak channels, K leaks out of the cell. Inside of the cell is more negative than outside. Small diamond depolarization. A stimulus causes Na channels to open. Na flows into the cell, right pointing arrow voltage becomes less negative. If threshold is reached, approximately -55 millivolts, action potential fire. The phrase, if threshold is reached, approximately -55 millivolts, action potential fires, means the following. Brain in simple terms. A neuron normally sits at a voltage of about -70 millivolts. This is its resting potential. When a stimulus, like a signal from another neuron, causes the inside of the neuron to become less negative, a process called depolarization, and this depolarization reaches a certain critical level, called the threshold, which is around -55 millivolts, the neuron will suddenly and rapidly fire an action potential. High voltage. What happens at threshold? Voltage-gated Na channels open. A huge influx of Na ions rushes into the neuron. This causes a rapid rise in voltage, up to around +30 millivolts. That rising signal travels down the axon. This is the nerve impulse. Checkmark key point. -55 millivolts is the point of no return. If the membrane reaches this voltage, the action potential must happen, like pulling a trigger. If the membrane doesn't reach -55 millivolts, the signal dies out and nothing fires. Propagation. Depolarization spreads as Na channels open in sequence along the axon. This allows the action potential to travel down the axon. Small diamond axon terminal, synapse. Arrival of action potential causes Ca² channels to open. Ca² enters the axon terminal, triggers neurotransmitter release. Vesicles containing neurotransmitters fuse with the membrane. Release contents into synaptic cleft via exocytosis.